Welcome to Dee-wy Academy. In today's lesson, we'll be learning conversion from base 10 to other bases. Converting from base 10 to any other base is done by continuous division of the base 10 number by the base number you want to convert to. For example, when you want to convert to base 2, which is the binary, you divide it by 2, which is continuous division by 2. If you want to convert it to octal, which is base 8, you do that by continuous division of what? 8. If you want to convert it to hexadecimal, which is base 16, you do that by continuous division of 16. After the division, you then write out the remainders at each stage of division until the quotient, that is the number you are dividing, is 0. The required new base is the remainders read from the bottom to top, that is from the least to the first. Example 1. Express 107 in base 10 to base 8. It means that we will do continuous division with the base number we are converting to, which is 8. For our division, we put up a table of division and the remainders. We are going to continuously divide 107 by 8. When you divide 107 divided by 8, we have 13. And the remainder is what? 3. We will now divide this 13 by 8. When you divide 13 by 8, you have 1. And the remainder is 5. We divide this 1 by 8. When you divide 1 by 8, you have 0. And the remainder is what? 1. So you can see that from 107, we do continuous division with 8. Where you divide 107 by 8, you have 13, remaining 3. When you divide 13 by 8, you have 1, remaining 5. When you divide 1 by 8, is 0, remaining 1. So the required base 8 number is read from the bottom to top, as shown in the arrow. If you read it from the bottom to top, you will have 153 base 8. Let's take another example. Example 2. Convert 10 in base 10 to base 2 value. Solution. We have 10. When you divide it by 2, you have 5. And the remainder is what? 0. We now divide 5 by 2. We have 2. And the remainder is 1. If we divide 2 by 2, we have 1. And the remainder is 0. We now divide 1 by 2. We have 0. And the remainder is 1. The required base 2 number is read from the bottom to top, which is equal to 1010 base 2. Let's take another example. Example 3. We are going to convert 254 in base 10 to base 16. Solution. We plot our table of continuous division with the remainders. We are going to continuously divide 254 by 16. When you divide 254 by 16, you have 15. And the remainder is what? 14. 15 divided by 16, we have 0. And the remainder is 15. Now, the required base 16 is read from the bottom to top, which gives 15, 14 in base 16. But remember, in base 16, all the unit values are expected to be only 1 unit up to the value 16. It's only when you reach 16 you now turn to 2-digit value. So here we are having 15 and 14, which are expected to be only 1 digit. Then in base 16, 10 is represented with A, 11 is represented with B, 12 is represented with C, 13 is represented with D, 14 is represented with E, and 15 is represented with F. All these are single units. When you now compare this with our answer, we have 15 to be F and 14 to be E. The required base 16 to be FE, base 16. And our final answer is FE, base 16. We have come to the end of the lesson. Support us with like, share, and subscribe for more math lessons. If you have any questions or topics you would like us to cover in future lessons, please drop a comment below. We love hearing from you. Thank you.